Hi everyone, welcome to another CP Algebra 2 video. This is Miss Bergeron. Like Miss VT said, we'll be alternating who makes videos, so sometimes it will be me. The one thing I wanted to note on this page is my office hours did change, so I have 2A, 3A, and 3B off. So if you wrote those down somewhere, you might want to change that. But I look forward to working with you guys through video and in person. Before we get started, if you go back, you should have either the notes for function operations in front of you, if you were able to print those out. If not, you can easily just do this on a line sheet of paper or any paper you have available. So today we're going to talk about function operations, which we're going to talk about adding, subtracting, and multiplying. If from Algebra 1 you remember adding and subtracting polynomials, this will look very similar. So let's get started. So our first example says given f of x equals x minus 6 and g of x equals 2x minus 4, it wants me to find f of x plus g of x. So I am just going to replace my f of x with the function that I have. So instead of writing f of x, I'll write x minus 6, and then I'll add g of x to that, which is 2x minus 4. And then really with addition, once I've written it here, I don't have to do much more than that. I'm just going to combine like terms to simplify it. So if we remember from Algebra 1, these x's would be like terms. So x plus 2x would give me 3x. And then I have negative 6 and negative 4 are like terms, and that would give me negative 10. So when I add these two functions together, it gives me this function here, 3x minus 10. For addition, I wrote the f of x first because it came first here. For addition, we know that addition is commutative, so it doesn't really matter the order that you write them. For subtraction, it does. So you want to be very intentional. For example, this says write g of x first. So that means I have to write g of x as my first function. So I'll write my 2x minus 4. And then I'm going to subtract. And anytime I'm subtracting, I'm going to put it in parentheses. And I'll explain why in a second. But I'm going to subtract my f function, which is x minus 6. So now, the reason I put this in parentheses is because this subtraction sign is going to the entire function, not just the first term. So if you think of this as like a negative 1, we would have to distribute that to both terms inside the parentheses. That subtraction is subtracting both of our terms. So it's saying minus x minus negative 6. But to make sure that we don't make a mistake, we'll just distribute the negative so that all the terms have the correct sign. So this is really 2x minus 4 minus 1x, and then negative 1 times negative 6 would give me positive 6. So now I've distributed that subtraction, or just distributed that minus sign to the entire function. And now, just like the addition problem, I'll combine like terms. So I have 2x, and now negative 1x would just leave me with x. And then negative 4 and positive 6 leaves me with positive 2. So when I combine these two functions together with subtraction, I'm left with the function x plus 2. All right, so let's look at the next two examples. So if my functions now, it says f of x is x squared minus 2x minus 4, and g of x is 3x plus 7. So this first question is asking us to add. So again, I replace f of x with whatever this function is, and then I'm adding my g of x function, which if we put in parentheses, like the habit we're going to make for subtraction, that's fine. You're just distributing a positive 1 here, so then that's not going to change the signs of these. So writing this in parentheses could be a good habit if you're afraid you're going to forget to do that for subtraction, but that wouldn't change any of the values because distributing a positive 1 would still leave this as 3x and positive 7. So then once I have the two functions, I'm just combining like terms. So I have nothing to combine with my x squared term, so I just bring that as part of my answer. And then positive 3x and negative 2x make positive 1x. And then positive 7 and negative 4 give me positive 3. So this would be the most simplified answer to adding those two functions together. So then number 4 is asking me to do f of x first. So remember when we do subtraction, order matters. So I'm going to write my f of x function first. And then I'm subtracting the entire g of x function. Because sometimes, again, the reason we put this in parentheses, if you didn't put it in parentheses and you just wrote it out and you put your minus sign, most of us would forget that you're subtracting the whole function and we would leave this as a positive 7. But then when I combine, that's going to give me a completely different answer than when I distribute my negative. So we want to make sure we have those parentheses. Because when I distribute this negative, that's going to give me a negative 3x and a negative 7, right? If I think of this as a negative 1 times positive 7 gives me a negative 7. Now that I have distributed my negative and gotten rid of the parentheses, I can just combine like terms. So again, there's nothing to combine with my x squared term, so just bring that down. Negative 2x and negative 3x make negative 5x. Negative 4 and negative 7 make negative 11. So when I combine all my like terms, this is what I get. So go ahead and pause the video and try number 5 and 6, and I'll come back and go over it real quickly together. All right, so if you solve numbers 5 and 6, again, for my function f of x, I wrote x minus 5. For g of x, I wrote x squared plus x minus 6. So then when I combine like terms, my x squared had nothing to combine with, so I just carried that over. Then I have 1x plus 1x gives me 2x, and negative 5 and negative 6 give me negative 11. Then for number 6, I had x minus 5 minus x squared plus x minus 6. So then remember, I'm distributing this negative 1 to every term. So then I get negative x squared, negative x, and positive 6. Because negative 1 times x squared gives me negative x squared. Negative 1 times x gives me negative x. Negative 1 times negative 6 would give me positive 6. So then when I combine my like terms, there's nothing to combine with x squared, my negative x squared term, so I just bring that over to my answer. Then I have positive x and negative x, which cancel each other out, right? 1 minus 1. And then I have negative 5 plus 6, which gives me a positive 1 as my answer. So that's adding and subtracting functions. So now we're going to look at multiplying functions. So if you go to the next page or just turn the page, make room in your notes, we're going to talk about multiplying functions. For multiplying functions, there's a couple different formats that you can see the question. So sometimes they'll separate it just by our multiplication dot. You could also see it where they have a dot. They put f times g of x. And then sometimes they don't even put the x. They just put f times g. All of these just mean multiply the two functions together. They're just different notations, but we solve them all exactly the same. So if we look at our first example for multiplying, it's asking us to multiply f of x times g of x. So we replace f of x with what it equals, so our function, which is 4x. And then we're going to multiply that by our next function, which is g of x, so that's 3x squared minus 2x minus 2. And we put that in parentheses because we're multiplying this whole function by this whole function. So we often will put the second one or both of them in parentheses. You have seen multiplication of polynomials like this before in Algebra 1. When you have one term multiplied by a polynomial, you would distribute. So I would distribute this 4x to all three terms. So 4x times 3x squared would give me 12x cubed. 4 times 3 is 12. X times x squared, I had 1x here, times 2x's here gives me 3x's. So then I do 4x times negative 2x, which would give me negative 8x squared. And then 4x times negative 2 would give me negative 8x. And then we would look to see if there's any like terms to be combined. There is not, so this would be my most simplified answer. So if we look at our next example, it's asking us to multiply our function f of x, which is 2x minus 5, times our function g of x, which is 3x plus 1. So again, we're just going to write them like we would when we multiply polynomials together. I'm multiplying 2x minus 5 times 3x plus 1. If you remember again from Algebra 1, when you have two terms, a binomial times two terms, a binomial, you would use FOIL, first, outside, inside, last, to multiply. So I'm going to multiply 2x times 3x. That means the first term in the polynomial, both polynomials. So 2x times 3x would give me 6x squared. Then I'm going to multiply the outside terms, so this term and my 1. So 2x times 1 would give me 2x. Then I multiply the inside terms together. So negative 5 times 3x gives me negative 15x. And then negative 5 times 1 gives me negative 5. So I've multiplied each term together, and now I would look to see if there's any like terms that I can combine, which would be 2x and negative 15x. So I would end up with 6x squared minus 13x minus 5. 2x minus 15x would leave me with negative 13x. So there would be my solution. So then for our last example, again, I'm just multiplying my two functions together. So I have 2x plus 3 times x squared minus 3x plus 7. And when we multiply, even when we FOIL, all we're doing is making sure we multiply each term by the term in the other polynomial. So I'm just making sure 2x goes to both of these terms, and then negative 5 goes to both of these terms. We do the same thing here. So I'm going to make sure 2x gets multiplied by all three terms here. And then I'm going to make sure 3 gets multiplied by all three terms here. So if I do 2x times x squared first, that would give me 2x cubed. Then I do 2x times negative 3x, would give me negative 6x squared. Then I do 2x times 7, which would give me 14x. So that was multiplying 2x by all three terms. So now I multiply 3 by all three terms. So 3 times x squared would give me 3x squared. 3 times negative 3x gives me negative 9x. And then 3 times 7 would give me 21. So then the last piece of that would be to combine like terms. So I don't have anything to combine with my 2x cubed, so I can just bring that down. Negative 6x squared and 3x squared would give me negative 3x squared. Then I have 14x minus 9x, which would then give me 5x. And then there's nothing to combine with my last term, that plus 21, so I bring that down for my final answer. So hopefully that was enough information to get you through some practice. If not, feel free to go back and watch the videos or to ask questions during our Monday or remote day or in class. But what I'd like you to do is go to your workbook and practice on pages 6. You'll do only 17 through 25. So on page 6, you can kind of skip the top half and you're just doing 17 through 25. And then all of page 7. So some of them are labeled by numbers and some of them are just called examples, but I want you to do every example and problem you see on page 7, and then you'll upload that to Schoology. All right, I look forward to seeing you guys in class.